Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, New St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, Crossing New Frontiers to Conquer Today's Challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, New St. Augustine.
My contribution to physics is this. Before my experimental discovery of the massively parallel processing supercomputer that occurred on the 4th of July of 1989, the most extreme scale computational physics codes were only executed on only one supercomputer. After my experimental discovery of the massively parallel processing supercomputer, the most extreme scaled computational physics codes were only executed across millions upon millions of commodity off-the-shelf processors. The precondition to experimentally discovering how to execute the fastest computations across my ensemble of processors and how to do so as one seamless cohesive unit that is a new supercomputer and that is a new internet required that I invent new techniques for sending emails that I visualized as having 5 subject lines and receiving emails that I visualized as having 3 subject lines and sending and receiving those emails to and from 2 to the power 16 or 65,536 16-bit long email addresses, each with no @ sign or .com suffix. In the 1980s, the Department of Energy of the United States government classified the most extreme scale problems in computational physics as grand challenges in supercomputing and as the toughest problems in physics. For me, Philip Emeagwali, to solve the grand challenge problem that was described as extreme scale petroleum reservoir simulation demanded that I be able to extend the frontiers of modern calculus and extend that frontier of knowledge by a distance of 9 partial differential equations of modern calculus and also extend the frontier of modern algebra by a distance of 9 partial difference equations and extend both frontiers of knowledge from the blackboard to the motherboard and extend those frontiers of knowledge across an ensemble of 2 to the power 16 processors that were married together as one cohesive unit and married by 16 times 2 to the power 16 or 1,048,576 bidirectional email wires. Those email wires has a 1-to-1 correspondence to the as many bidirectional edges of the hypercube in the 16th dimensional hyperspace. That is, the lone wolf inventor of the new supercomputer that is a new internet must be a jack of all sciences. The lone wolf inventor of that new internet must be a Renaissance person that is a multidisciplinary trait that can simultaneously extend the boundaries of human knowledge and extend that boundary across computational physics, modern calculus, extreme scale algebra, fastest supercomputer, and a new internet. In summary, we knew the land before parallel processing, and we named that land sequential processing or computing only one thing at a time. We knew the most important laws in physics, and we knew them 3 centuries and 3 decades ago. We knew how to encode those laws of physics as the most advanced expressions in calculus called partial differential equations. And we knew them nearly a century and a half ago. We knew how to discretize those partial differential equations to their algebraic approximations. And we knew them almost a century ago. We knew how to further reduce the systems of equations of algebra and how to reduce them to an equivalent set of floating point arithmetical operations. And we knew them over half a century ago. We had been executing those floating point arithmetical operations since 1946, the year the first digital programmable supercomputer was invented. We knew the land before parallel processing as the land where we computed one thing at a time. In the 1980s, we did not know the land after sequential processing or computing many things at once. What made the news headlines in 1989 was that I did something that was considered physically impossible to do. Namely, I crossed from the land of sequential processing to the land of parallel processing. What made the news headlines was that I experimentally discovered how to solve the most computation-intensive problems of extreme-scale computational physics. On the 4th of July of 1989, I experimentally discovered how to solve those grand challenge problems and how to solve them across 65,536 commodity off-the-shelf processors or across as many identical computers that outline a small internet. The supercomputing community confirmed my discovery, and the June 20, 1990 issue of the Wall Street Journal recorded that I, Philip Emeagwali, had experimentally discovered that we can massively parallel process, and that I discovered it via emails I sent to 16-bit long addresses that each had no @ or .com suffix, and via emails I sent across a small internet. That small internet is a global network of 65,536 commodity processors, or as many identical computers. Finally, I must add that solving the grand challenge problem of computational physics sharpened and deepened our understanding of both the computer and the supercomputer and changed the way we look at both technologies. The modern supercomputer that computes faster by massively parallel processing across millions of processors is the fastest computer in the world. The massively parallel processing supercomputer became the world's fastest computer by computing many things at once instead of computing only one thing at a time. The modern supercomputer that solves billions of problems at once instead of solving only one problem at a time helps make the world a more knowledgeable place. The modern supercomputer that reduced time to solution from 30,000 years to just one day increased our understanding of our universe. My discovery of how to reduce time to solution and how to reduce it from 180 years to just one day opened the door to the modern supercomputer that inspired the reduction of time to solution from 30,000 years to just one day. I'm Philip Emeagwali. I've posted at emeagwali.com the complete version of this lecture. Go to my website and look for my video-taped lecture series on how I experimentally discovered that massively parallel processing could be harnessed as the driving force of the computer and the internet. That discovery paved the way for the modern supercomputer. For me, Philip Emeagwali, I find it unsettling to see a modern inventor that did not articulate his invention in videotape lectures. These modern inventors never left a videotaped recording of how they invented and what they invented. The absence of videotaped lectures reduces discussions of their inventions to endless he said, she said. About 4 centuries ago, my most distant ancestor that I know by name, named Ezechima, lived in present-day Nigeria, West Africa. Ezechima led a human wave of refugees that were fleeing from the tyrannical rule of Oba Esije, who lived from 1504 to 1550, or King of Benin, and his slave raiders that sought slaves for the earliest slave traders, such as the Englishman John Hawkins, who sold my ancestors off to the island of Hispaniola, meaning Little Spain. That Ireland that was near Haiti was quote-unquote discovered by Christopher Columbus and discovered on the 5th of December of 1492. Some of my ancestors were captured by the Oba of Benin and survived the Middle Passage across the Atlantic Ocean. The African names of my ancestors that crossed the Atlantic Ocean, such as those named Emeagwali, were lost in the mist of time. My ancestors that were captured as slaves are in the 200 million African diaspora that are living in countries like Brazil, Jamaica, and the United States. Ezechima and some of my ancestors that escaped from the slave trade raiders fled towards Onitsha in modern-day Nigeria. Onitsha is my ancestral hometown in Igbo land. Ezechima fled from the slave raiders and fled with no map to guide him in his flight from Benin to Onitsha, Igbo land. The big question, or the terra incognita for Ezechima was, what lied beyond Igbo land? To Ezechima, the Atlantic Ocean was a terra incognita called Ani Ndemmo, or the land of the spirits. The Atlantic Ocean was a 150-mile boat ride from the river Niger at Onitsha. Back in the 16th century, the Atlantic Ocean was vast and endless, and crossing the Atlantic Ocean was my metaphor for experimentally discovering how to harness the total supercomputing power of my ensemble of 65,536 processors. I began programming supercomputers on June 20, 1974 in Corvallis, Oregon, United States, and at age 19. As a 19-year-old supercomputer programmer, I felt like the child that was put in command of an ocean liner. At its core, my biggest question was the same for Ezechima. The big question for Ezechima was, who will climb into a dugout canoe at the banks of the River Niger at Onitsha and paddle the canoe to find out where the world ends? Who will find out where the River Niger began or where the River Niger ended? Who will visit the kingdom at the bottomless ocean floor that is the home of the mermaid called Mami Water or Eze Nwanyi Mmiri? The big question for the distant descendant of Ezechima, Philip Emeagwali, who voluntarily came to the Americas by airplane, not involuntarily by ship, was, can an ensemble of the slowest processors outperform the fastest supercomputer and change the way we look at the modern computer? For the 15 years onward of June 20, 1974, this parallel processing research project kept me up at night in the final days leading to the experimental discovery of massively parallel processing, a discovery that occurred on the 4th of July of 1989. I had my heart in my throat. I had the visceral feeling that my massively parallel processing supercomputer results were historic. That experimental discovery of the massively parallel processing supercomputer is the reason children are writing school reports titled "The Contributions of Philip Emeagwali to the Development of the Computer." I am an African-born computational mathematician that followed in the footsteps of ancient African-born mathematicians. The oldest mathematics literature was excavated in Africa, and it was written in 1550 BC, and it was written by Hermes. The African mathematician named Euclid is the father of geometry. And as far as the historical records revealed, the 2,300-year-old DNA of Euclid originated from Africa, and 2,300 years later, the DNA of Euclid remains in Africa. Euclid lived in North Africa and lived at a time North Africa was predominantly black. As a torchbearer, I had to give voice to my voiceless ancestors, and I had to construct the narrative of Africa's contributions to mathematical knowledge. That was how I, Philip Emeagwali, became the bearer of Africa's contributions to human knowledge. Daalụnụ, afam bụ Chukwura Philip Emeagwali. Abụ m onye Ọnịcha. Bịa ga-afụ m na emeagwali.com ka o mesịa. I'm Philip Emeagwali at emeagwali.com. Thank you.
Insightful and brilliant lecture.
Thank you.